Hi everyone, I am Kusuma and my teammate is Tejashwini GM. We are explain about my project named Enhanced Solar Power Forecasting using support vector regression with diagnostic extension. First come to abstract of this project. In this abstract of this project, this extend study build on the work and Abela and Chaudhary in 2016, who developed a solar power forecasting pipeline using support vector regression and forecasting pipeline using support vector regression with the real meteorologic data. Our contribution in this project is we argument their methodology using diagnostic interpretability tools and systematic data sets is used the demonstration purpose. Tools are used for permutation future importance and residual error analysis and prediction distribution visualization, and this improvement of deeper insights into model performance and behavior. Next is introduction. In this introduction part, the solar forecasting is essential for the successful integration of renewable energy into the grid, and Avila and Chaudhary proved the SVR is effective using real weather future, and our studies extended work by incorporating interpretability and diagnostic tools. A synthetic dataset is used to demonstrate this concept clearly in a controlled environment. The methodology overview and this project is the data synthetic dataset is thousands of sample is there in this future. There is this project. The future of this project is total cloud cover and temperature, solar radiation and prediction is there, and model of this project is SVR with RBF kernel, and optimization of this grid search CV used to tune parameters of this, and the best parameter of C is equal to 0.1 and gamma is scale, and epsilon is 0.2, and evaluation of this matrix is root mean squared error, RMSE means 0.1863 is R square score. Next is prediction histogram. This histogram was plotted for the predicted solar power value. In this histogram, the x-axis is the range of the predicted power, and y-axis is frequency of prediction in each range. This helps to visualize how prediction are distributed. Next is result and output. Achieved a low RMSE of 0.1x63, indicating good prediction performance in this project, and diagnostics tools are helpful to validate the model robustness and validate the model the robustness and this understand the prediction error and identify the potential important of areas. Is enhanced pipelines equals deeper insights into the model behavior in this project. Next is last part of the this project's explanation is conclusion. The conclusion, we recreate and extend the Abela and Chowdhury solar forecasting model using synthetic data and added tool improve the interpretability and trusting SVR prediction, and diagnostics tools are circular for building a reliable solar forecasting system. These advanced support confident and real-world deployments of data-driven energy models are so much in this project is and this and in this study we have received a solar power forecasting model originally developed by Abela and Chowdhury, which used the support vector regression to predict solar energy based on weather data. What sets our work apart is the didn't just replicate their method, and we enhanced it by using a synthetic dataset. We create a controlled environment where we cloud safety and clearly test new features without dealing with the complexity of real world data. And we added the diagnostic of interpretability tools such as permutation feature, importance to understand which features had most impact on prediction, and residual error analysis to examine where and why model made mistake, and prediction distribution is a visualization means histograms to see how two models are output were spread. And these tools are not just techniques extract, they are essential for gaining confidence in how the model are behaves, and identify the weaknesses of our basis, and making sure this model isn't reliable before using it in a real world solar energy forecasting system. In short, our important health bridge the gap between raw machines learning models and trustworthy decision making tools for energy system. These are the what about this project here, theory part of this project. In next programming part of this project, she explained by my teammate Tejashri GM. Thank you so much.
Importing libraries like NumPy and Pandas. NumPy and Pandas is used for numerical operations and dataset, and Matplotlib is used for data visualization and cyclic load SVR models. Here I am going to create data frames, data frames, and features like a DCCC, 2D, SSRD, TP, solar power. Data.head it displays the first seven first 7 rows of the data column, and synthetic data sample and 100,000 synthetic samples is generated here. Features like TCCC, 2T, SSRT, TP, and solar power. Pre-processing the data. features, and here we use the preprocessed data, and it displays the y, and it displays the x and y is the targeted variables, and this I is the targeted data.info. It displays the information about the dataset, and checking the null values is there or not, and data.columns. Here I am going to check how many columns is there in data set, and train and test splits. In this data, we can divide the split data sets into a 80% of test data and 20% of trained data. Yeah, we use the algorithm like grid search CV, and creating, and shows the EDA, displays the EDA format, mesh models, grid search, and plotting. In this cell, we are EDA performs the plot, comparing the plot actual versus the predicted values by using the plot line plot. Here in this we in this code we are extending the three features, like feature first one is feature importance biopermutations, calculating the permutations importance, and creating a data frame for visualizations, and visualizing features important. Here comparing the feature importance with bar chart. Residential in second extension residential. Calculating the residentials. Here setting up plot sets, creating a scatter plot, adding references lines, customize the plot. Residential comparing the residential versus the predicted values. Extension 3, prediction histogram. Histogram shows adjusting the KDE curve. Here adjusting the KDE curve, figure size is 6,4, and histogram shows the frequency of the predicted values falling into each bin. KDE curve provides the smoothed estimation of the distribution, making it easier to identify identify the patterns such as the skew, this modularity. By comparing both, again, comprehensive view of how our model's predictions are distributed, which is valuable for assessing the model performance and identifying the potential issues. Here I am using a data set from extracting from a Kaggle. In this data set, we are 1000 rows are there. Thank you.